The tree of humanity has always been a puzzle made of bones and ghosts. Each fossil is like a fragment of memory, a whisper from the deep past, promising answers, yet leaving behind more questions. For more than a century, scientists have searched for the roots of our species, tracing scattered clues across continents, piecing together what it means to be human. But the picture is still incomplete. In this mystery, three figures stand out like shadows at the edge of a fire: the ghostly Denisovans, known only through fragments of DNA, the Hobbit of Flores, whose tiny bones defied every rule of evolution, and the massive Narmada skull, from India, too ancient, too modern, too complex to fit neatly anywhere. For generations, we have repeated one story, that humanity's cradle lay in Africa, and from there our ancestors marched outward to populate the world. But what if that story is not the whole truth? What if Asia was not just a stage upon which humans wandered, but the birthplace of our kind, a crucible where evolution experimented with every possible form, small, large, fragile, and fierce, in this journey? We will uncover how new discoveries are rewriting that story, how DNA, hidden inside fossil dust, can reveal the face of a lost people, how chemical marks on ancient bones can recreate the shape of their skulls, how islands turned giants into dwarfs, and how migrations once thought to be one way may have flowed back again. The past is calling from beneath the soil, from Georgia to Java, from the high plateaus of Tibet to the plains of India. To find the truth, we must follow the bones and let them tell their story once more. When we trace the earliest footsteps of our kind, the trail doesn't begin in just one place. It spreads like rivers branching from the same mountain-carving paths across continents. For decades, textbooks told us that Homo erectus, our upright ancestor, was born in Africa 2 million years ago and then marched eastward into Asia. But the bones, quiet and ancient, seem to be telling a more complicated story, one where Asia might have spoken first. In the rolling hills of Georgia, at a site called Dmanisi, archaeologists uncovered a startling scene frozen in time. Nearly 1.85 million years old, these fossils belong to small-bodied humans with delicate limbs and primitive skulls far earlier than anyone expected outside Africa. Their faces were unlike ours, but their courage was unmistakable. They had wandered thousands of miles from home, carrying the fire of exploration long before modern humans existed. Farther east, in Yuanmo, China, a pair of fossilized front teeth, dated to about 1.7 million years ago, whispered another truth. Not long after, at Gongwangling, a partial skull about 1.63 million years old surfaced, showing erectus-like features that echoed the Dmanisi forms. These remains weren't latecomers, they were pioneers. Meanwhile, in the humid plains of Java, fossils from Sangiran, nearly 1.3 to 1.5 million years old, revealed that early humans had already reached the islands of Southeast Asia, adapting to new climates, new predators, new worlds. When we compare these Asian discoveries with the famous African sites of Kubifora and West Turkana, both roughly 1.7 million years old, something extraordinary emerges. The timelines overlap almost perfectly. There isn't a clear before and after. Instead, it looks like two branches of humanity growing side by side, separated by deserts and seas, but born of the same restless spark. This overlap forces us to question a story we thought we knew. Perhaps Homo erectus didn't just leave Africa. It may have arisen and diversified across a broader region, with populations moving back and forth for hundreds of thousands of years. Evolution, after all, is rarely a straight path. It's a network of journeys, of departures and returns. The fossils in Asia don't whisper of isolation. They tell a story of connection, of movement, of innovation. They suggest that the early humans who stood on the shores of Java and in the valleys of China were not simply recipients of an African legacy, they were co-authors of the human story. And so we're left with a question that reshapes everything. Did the first sparks of humanity ignite under Asian skies south of the equator on the remote island of Flores in Indonesia? A cave called Liang Bua hides one of the strangest chapters in human history. In 2003, archaeologists brushed away layers of volcanic dust and found a skeleton so small it seemed almost mythical. The creature stood barely 1 meter tall, with a brain smaller than a chimpanzee's, yet around it lay stone tools sharp enough to butcher animals. It had lived alongside pygmy elephants called stegodons and hunted them with precision. At first, many scientists refused to believe. They called it a deformity, a diseased modern human, a mistake. But the bones were stubborn. They told another story. That story deepened in 2024 and 2025, when excavations at Mata Menge, just 60 miles away, uncovered even older fossils, about 7,000,000 years old. A tiny humerus teeth no larger than a child's, all perfectly proportioned. These weren't shrunken moderns. They were descendants of an early Homo erectus population that had been stranded on an island and sculpted by evolution into a new form, Homo floresiensis, the Hobbit of Flores. Their small bodies weren't a flaw of nature, they were an adaptation. This is a classic case of island dwarfism, a rule of evolution seen from mammoths to hippos to humans. When species are trapped on isolated islands with limited food and no large predators, natural selection favors the small. Less size means less hunger, and less hunger means survival. Over thousands of generations, bodies shrink, but intelligence finds new ways to thrive. The hobbits made tools, controlled fire, and endured for hundreds of millennia. In the end, they vanished about 6,000 years ago, leaving behind bones that seem to laugh at our assumptions. They remind us that intellect doesn't always require a big brain, and progress doesn't always move in a straight line. They didn't shrink in mind, only in bone. And in their tiny hands they held proof that Asia was not merely a witness to human evolution, but its workshop, a place where isolation, creativity and survival rewrote what it means to be human. For years, the Denisovans were the ghosts of our family tree, a people known only from traces of ancient DNA extracted from a finger bone in a Siberian cave. No one had ever seen their faces. They were everywhere in our genes and nowhere in our museums. Scientists could sequence their DNA, but they could not picture the beings behind it. That mystery began to fade when technology finally gave form to the invisible. By 2025, researchers developed a method called gene regulatory phenotype mapping, also known as methylation profiling. Every cell in the body carries not only genetic code but chemical markers, tiny switches that turn genes on or off, shaping how bones, muscles and faces form. By reading those patterns in Denisovan DNA, scientists could predict physical traits, reconstructing a virtual skull with 18 distinct features: the slope of the forehead, the width of the jaw, the shape of the brow. For the first time, we could look at a ghost and see a face staring back. Armed with this molecular blueprint, paleoanthropologists re-examined dozens of mysterious fossils from across the Old World. Among them, 3 stood out as extraordinary matches. The first was Harbin, the so-called Dragon Man from northern China. In 2025, protein and mitochondrial DNA tests confirmed what the methylation map had already hinted. Harbin belonged to the Denisovan branch. Nearby, the Dali skull with 15 of 18 predicted traits appeared as Harbin's near twin, massive, broad-faced, yet distinctly human. Even fossils far from Asia began to whisper the same story. In Kabwe, Zambia and Petrolona, Greece's robust crania shared remarkable similarities, suggesting that Denisovan-like forms once stretched across continents. The genetic web reached even further west. At Cima de los Huesos in Spain, DNA from 430,000-year-old bones revealed a surprising mixture: Denisovan-like mitochondrial DNA, but Neanderthal nuclear DNA. It was as if these lineages had met, mingled and diverged again, leaving behind a tangled ancestry that defied the neat lines of our textbooks. Humanity, it turned out, was never a single story, but a braided river of genes flowing across time. And the Denisovans are not gone. Their signatures still live within us. People in Papua New Guinea and Melanesia carry 4 to 6% of their DNA, while high-altitude populations in Tibet owe their unique adaptation to thin air to a Denisovan gene called EPAS, a gift from an ancient cousin that helps their blood draw oxygen efficiently. So the ghosts were never just phantoms of the East. They were bridges linking Asia, Africa, and Europe through shared ancestry and exchange. The Denisovans remind us that our origins were never isolated, that the human story is not confined to one cradle but spread across a network of ancient worlds, woven together by migrations, encounters, and the enduring memory written in our DNA. While the tiny hobbits of Flores were shrinking under island skies, another lineage of humans was taking shape across the vast plains of India. Here, amid dry riverbeds and red cliffs, a massive skull was unearthed near the Narmada River, a fossil so powerful in form it seemed carved from stone itself. The Narmada skull had walls as thick as armor brow ridges, bold and heavy, yet inside a cranial capacity almost equal to modern humans. It was both ancient and advanced, a paradox in bone. Scientists could not agree, was it a late Homo erectus, an early Homo sapiens, or something in between, a missing link in the great human experiment. When compared to other fossils of the same era, the Narmada skull found its company. In Kabwe, Zambia, the famous Broken Hill skull revealed similar strength and proportion. A wide face, deep orbits a brain that pushed toward modern size. Across the Mediterranean, the Petrolona skull in Greece shared that same combination of archaic toughness and emerging modernity. Together, these fossils formed what researchers now call a Middle Pleistocene robust cluster, evidence of a broad population spread across continents built from the same sturdy blueprint. Genetic and morphological studies suggest that Narmada may be a sister lineage to Asian Homo erectus, or perhaps a cousin close to Homo heidelbergensis, the ancestor of both Neanderthals and modern humans. This places India not on the sidelines of human evolution, but right in the middle of the crossroads where lineages met and diverged. The environment shaped them just as powerfully as isolation shaped the hobbits. On Flores, limited food and island confinement shrank the body and the brain. In Narmada's world, open plains, abundant prey and wide hunting grounds rewarded size and endurance. Two extremes, two answers to the same question of survival. From the smallest islanders to the mightiest plainsmen, Asia shaped them all. Each adapted to the land that held them, molded by scarcity or abundance, by confinement or freedom. Both the hobbit and the giant were children of the same ancestor, Homo erectus, shaped by circumstance, yet united by adaptability. And in that connection, we glimpse the deeper rhythm of evolution, not progress or perfection, but endless experimentation, each branch of humanity testing what it meant to endure. Across the span of continents and ages, three stories now weave into one. The Denisovans, the Hobbits of Flores, and the giants of Narmada, each so different in body, yet all born from the same ancestral flame, Homo erectus, the great wanderer of Asia. From the frozen caves of Siberia to the jungles of Indonesia and the river valleys of India, this single lineage splintered into forms that defy the simple ladder of evolution. Humanity, it turns out, is not a staircase leading upward, but a branching bush, a web of lives adapting in every direction. In this tangled bush, adaptability was the true genius of our kind. The Denisovans gave us the face of a ghost, reminding us that even the unseen can leave its mark within our blood. The Hobbit of Flores showed that wisdom and creativity can thrive inside the smallest of bodies, that survival is not measured in size, but in imagination. And the Narmada giant taught us that strength is not only in bone and muscle, but in the quiet persistence to endure. Each of them, ghost, dwarf and titan, stood as an experiment in being human. Together they revealed that evolution was never about perfection. It was about persistence, about finding countless ways to live, to adapt, to continue. Our ancestors were many, not one. To understand humanity is to embrace its branches, every ghost, every giant, every hobbit among us. And if we look upon a map of Asia, we see not just land and borders, but a glowing crucible, a place where humanity learned to adapt, to transform, and to thrive. This is the story written in our bones, a story still unfolding in every one of us.